Hello and welcome to the new video. At the end of the video, you will know how this Earth was created.
Our story begins roughly 4.6 billion years ago, in a time when the universe was still young and the solar system was just beginning to take shape. The vast expanse of space, though seemingly empty, held the remnants of dead stars, clouds of gas and dust. These remnants, the cosmic ashes of ancient stellar giants, floated aimlessly through the void, waiting for a force to bring them together. These particles, drawn together by gravity, danced a chaotic ballet. Gravity, the invisible hand of the cosmos, began to weave its magic, pulling these particles into a swirling, chaotic dance that would eventually lead to the birth of new celestial bodies. They swirled and collided, generating heat and pressure. Each collision, each impact added to the growing heat, creating a furnace of unimaginable temperatures and pressures. This maelstrom of cosmic debris coalesced, forming a spinning disk. This disk, a protoplanetary disk, was the nursery of our solar system where the seeds of planets were sown. At its center, a young star ignited, our sun. The birth of the sun was a cataclysmic event, a nuclear furnace that would provide the energy needed for the formation of planets.
Around it, the remaining material clumped together, forming the seeds of planets. Among them, our Earth. These clumps of matter, through countless collisions and mergers, grew larger and more defined, eventually becoming the planets we know today. Imagine Earth in its infancy, a molten sphere, bombarded by asteroids and comets. The young Earth was a hellish landscape, a molten world constantly reshaped by violent impacts. The relentless impacts generated intense heat, keeping the planet in a liquid state. Each collision added to the heat, preventing the surface from solidifying and creating a seething, molten landscape. Volcanoes erupted, spewing lava and gases into the primitive atmosphere. These eruptions were not just local events, they were global, reshaping the surface and contributing to the formation of an early atmosphere. This was a time of intense turmoil, a fiery crucible where the very building blocks of our planet were forged. The surface was a chaotic landscape of erupting volcanoes and flowing lava, a testament to the violent processes that shaped our world. As Earth cooled, a crust began to form on its surface, the first solid ground. Yet, the bombardment continued. The formation of the crust marked a significant milestone, but the young Earth was still far from stable. These impacts, though destructive, also delivered water and other volatile compounds, trapped within the rocky bodies from the outer reaches of the solar system. These compounds were crucial, as they would eventually contribute to the formation of Earth's oceans and atmosphere. These were the seeds of Earth's future oceans. The water and volatiles brought by these impacts began to accumulate, setting the stage for the formation of the first bodies of water. The early Earth was a hostile and alien place, far from the hospitable planet we know today. The surface was barren and rugged with little to no signs of life, a stark contrast to the vibrant world we inhabit now. But within this crucible of cosmic chaos, the stage was set for the greatest story ever told, the story of life. Despite the harsh conditions, the ingredients for life were being assembled, setting the stage for the emergence of the first living organisms. As Earth cooled over millions of years, a remarkable transformation began to take shape. The once molten surface solidified, forming the planet's very first crust. Volcanic activity, though still rampant, gradually began to subside. Water vapor, released during volcanic eruptions and delivered by icy comets, accumulated in the atmosphere. As temperatures continued to drop, the water vapor condensed into liquid form. Torrential rains lashed the planet's surface for millennia. Rivers of fire turned into raging torrents of water. These waters, carrying dissolved minerals from the rocks, collected in vast depressions, forming the first oceans. The formation of oceans was a pivotal moment in Earth's history. Water, the universal solvent, played a crucial role in shaping the planet's surface. It eroded rocks, carving canyons and shaping coastlines. More importantly, it provided a stable environment for the emergence of life. The early oceans, though teeming with dissolved minerals, were quite different from today's. They were likely warmer and more acidic. Yet, within these primordial waters, a profound transformation was about to unfold, the spark of life. The question of how life arose from non-living matter remains one of science's most intriguing mysteries. Scientists have long pondered the origins of life, seeking to understand the transition from simple molecules to complex organisms. This quest has led to numerous theories and experiments, each bringing us a step closer to unraveling the enigma of our beginnings. Around 3.8 billion years ago, in the depths of Earth's primordial oceans, the seemingly impossible occurred. The conditions of early Earth were vastly different from what we know today. Volcanic activity was rampant, and the atmosphere was thick with gases like methane and ammonia. Amidst this chaotic environment, the first building blocks of life began to form. In a process known as abiogenesis, the first life forms emerged. This process involved the gradual assembly of simple organic molecules into more complex structures, eventually leading to the formation of self-replicating entities. These early life forms were the precursors to all life on Earth, marking the dawn of biological evolution. These early life forms were simple, single-celled organisms, far less complex than even the simplest bacteria alive today. They lacked the intricate cellular machinery that characterizes modern life, yet they possessed the essential properties of life, the ability to grow, reproduce, and evolve. They inhabited a world without oxygen, relying on readily available energy sources from hydrothermal vents and chemical reactions. These vents, located on the ocean floor, spewed out mineral-rich water heated by the Earth's internal heat. This provided a unique environment where life could thrive, utilizing the chemical energy to fuel their metabolic processes. These were the pioneers of life, adapting and evolving in a harsh and ever-changing environment. Over time, they developed new strategies to survive, such as forming protective membranes and utilizing different energy sources. Their ability to adapt was crucial for their survival and laid the foundation for the diversity of life that would follow. Over millions of years, these early life forms diversified. They evolved into a myriad of different species, each adapted to their specific environments. This diversification was driven by natural selection, where the most successful organisms passed on their traits to the next generation. They developed mechanisms to copy themselves, passing on genetic information to their descendants. This process of replication was not perfect, leading to variations in the genetic code. These variations were the raw material for evolution, allowing life to adapt and thrive in an ever-changing world. Evolution, the driving force of life's diversity, had begun. Through countless generations, life forms continued to evolve, becoming more complex and specialized. This relentless process of change and adaptation has given rise to the vast array of life forms we see today, from the simplest bacteria to the most complex multicellular organisms. The tree of life, with its countless branches, had taken root. Each branch represents a different lineage of organisms, all tracing their origins back to those first simple life forms. This tree continues to grow and evolve, reflecting the dynamic and ever-changing nature of life on Earth. The emergence of life from non-living matter is a testament to the remarkable power of self-organization. It demonstrates how, under the right conditions, simple molecules can come together to form complex systems capable of growth and reproduction. This process is driven by the fundamental laws of physics and chemistry, which govern the behavior of matter and energy. Inherent in the laws of physics and chemistry, these laws provide the framework within which life can arise and evolve. They dictate how molecules interact, how energy is transferred, and how complex structures can emerge from simple beginnings. From simple molecules, complexity arose through a series of gradual steps, each building on the previous one. This process of increasing complexity is a hallmark of life, driving the evolution of more sophisticated organisms over time, ultimately giving rise to the incredible diversity of life we see today. From the smallest microorganisms to the largest animals, all life on Earth shares a common origin. This shared heritage is a reminder of the interconnectedness of all living things and the remarkable journey that life has taken over billions of years.
The early Earth's atmosphere was devoid of free oxygen. It was a time when the air was thick with gases like methane, ammonia, and water vapor, creating a hostile environment for the kind of life we are familiar with today. The planet was a vastly different place, with volcanic activity and a barren landscape dominating the scene. This began to change around 3.5 billion years ago, with the emergence of a new revolutionary life form, cyanobacteria. These microscopic organisms were among the first to develop the ability to perform photosynthesis, a process that would eventually alter the course of Earth's history. These single-celled organisms possessed a remarkable ability, photosynthesis. By capturing sunlight and using it to convert carbon dioxide and water into glucose, they not only produced energy for themselves but also released oxygen as a byproduct. This seemingly simple process had profound implications. They could harness sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. This oxygen began to accumulate in the oceans and eventually started to seep into the atmosphere, slowly transforming it. Cyanobacteria thrived in the sunlit waters of the ancient oceans. Their proliferation was not just a biological success, but a geological and atmospheric revolution. Over millions of years, these tiny organisms multiplied exponentially, creating vast colonies that could be seen from space if anyone had been there to look. As they multiplied, they released increasing amounts of oxygen into the atmosphere. This gradual increase in atmospheric oxygen set the stage for one of the most significant events in Earth's history. This marked a profound shift in Earth's history, the Great Oxygenation Event. Occurring around 2.4 billion years ago, this event saw a dramatic rise in atmospheric oxygen levels, fundamentally altering the planet's environment.
The rise of oxygen had dramatic consequences for life on Earth. It was a double-edged sword. While it enabled the evolution of complex life forms, it also posed a lethal threat to many existing anaerobic organisms. Initially, it was toxic to many anaerobic organisms, leading to a major extinction event. These organisms, which had thrived in an oxygen-free environment, found themselves unable to survive in the new, oxygen-rich atmosphere. However, oxygen also paved the way for the evolution of more complex life forms that could utilize this new energy source. The presence of oxygen allowed for more efficient energy production through aerobic respiration, which in turn supported the development of larger and more complex organisms. The rise of oxygen transformed the atmosphere, creating the ozone layer that shielded Earth from harmful ultraviolet radiation. This protective layer was crucial for the survival of life on land, as it allowed organisms to venture out of the oceans without being exposed to deadly UV rays. This set the stage for life to emerge from the oceans and colonize the land, ultimately leading to the world we know today. The rise of oxygen was not just a pivotal moment in Earth's history. It was the foundation upon which the diversity of life we see around us was built. If you are curious to know what the first inhabitants of Earth were after evolution, press the subscribe button, activate the notification bell, and don't forget to like and comment. Thank you for your support.